a student from Mariam College, Kutikanam. Today my topic is to present is automatic end queen solving using a Backtrack. I will explain what the end queen problem is and why is backtracking is used, how the algorithm works step by step, followed by an example demonstration and complexity analysis, evaluation, and the conclusion. Problem is a classic puzzle where we must place end coins on an end by end chessboard in such a way that two coins are attached attack each other. This means no two coins can be the same row, or no two coins can be in the same column, no two coins can be in the same diagonal. In this real world scenario, such as a puzzles, a game map, the system must automatically find a valid coin's positions once the user selects a board size. Since there is a many possible combinations, cannot check on each one manually. Therefore, we need an efficient algorithms. Topic is why backtracking is needed. A backtracking is used because the number of possible arrangements grows very quickly, many positions become invalid early, and brute force checking would waste the time. Backtracking follows a simple idea that is try, check, backtrack. The algorithm plays a QA, checks if it is safe, and it leads to a conflict. It removes that queen and tries another position, the avoiding the unnecessary calculations and the improvements performance. Explain an algorithm. First, we start from the first column. We try to place a coin in every row of that column. If the position is safe, we place the coin and move to the next column. Again, we try all the rows. If at any points no safe positions is available, we remove the previously placed coin and go back to the early column. Step is called backtracking. This process continues until a coins are safely placed. I will explain the pseudocode. So here this a function name is called as a function solve. Inside the function we passing a parameter columns for the short form code. If a code it is double equal to n, return true. Otherwise it will return the false. Next loop is for each row in a board. If safe row and column, then place the coin. If so, the column plus 1 and return true. And if this if loop is okay, then it removes the coin and return false. This is about a pseudocode. We see the data structure representation. So in this chessboard is a represents using a 2D array of matrix. The value 1 is represents a coin and value 0 is represent an empty cell. So recursive function calls manage the backtracking processing using the call stack. Video you can see the system plays the first coin, then it moves to the next column and tries to the another coin. When a conflict is occurs, the coin is removed automatically. This is show how the invalid positions are eliminated. Finally, after several trials and backtrackings, a valid arrangement of a coins is achieved. This is clearly demonstrating how the backtracking explores the possibilities and the removing wrong choice. Worst case of a time complexity is the order of n not equals because all the possible permutations may be explored. In the space complexity is order of n squares for restoring the board and order of n for the recursion the stack. Now we recursive calls increase rapidly, and the visuals may become a slow for a big boards. However, the backtracking is still appropriate because it is a systematically search solution. It avoids invalid paths early. It grants a correct results. And this make the ideal for a puzzles based on the applications. The end of the video. To conclude, the end puzzle problem is a constraint-based puzzles. Backtracking providing an efficient way to the solve it is exploring a valid positions and removing invalid ones. So the approach is widely used in game maps and logical problems ones. So throughout this project, we can understand the importance of recursion, precision, and the algorithm thinking. Listen this video. Have a nice day. Thank you.